All right, we're talking about scalar and vector projections, okay? So here are some formulas and rules I want you guys to know when going over this. A scalar projection of A on B, okay, is ON, where ON is equal to the magnitude of A multiplied by cos theta. Oh, that's right, theta in the first one. This will be our theta. So the first example is when we have something that is an angle that is less than 90 degrees. Example 2 is when we have an angle that is greater than 90 degrees. And example 3 is when we have a 90-degree angle. Essentially, there is no ON because cos 90 is going to be what? 0. And 0 times the magnitude of anything is still going to be the number 0. Okay. So this just gives you a general idea of what we're looking for when doing this. Also, scalar projections. Okay, these are two other rules I want you guys to know. A scalar projection of A on B is the dot product of A and B divided by the magnitude of B. This is a formula. And same idea, scalar projection of B on A. So the opposite is vector A dot B over the magnitude of A. Generally, these are not equal. Okay, so one projection onto the other usually gives us a different number. And what we're going to do is we're going to jump ahead to example 2, and we're going to take a look at example 2 and exactly what they mean by this. So, example number 2. There you go. It says for vector A, vector A is -3, 4, and 5 times root 3. And vector B is -2, 2, and -1. And it says to calculate each of the following scalar projections. So the first one says a projection of A on B, and then they also want us to calculate a projection of B on A. Now these are scalar projections here. Okay. So we need to remember our formula when going through this. A on B becomes the dot product of A and B, which will be the same in both, over the absolute value or the magnitude of B. Where in our other one, we're over the absolute value or magnitude of vector A. We'll still use the same dot product above. Okay. If you guys remember our dot product rule from before, A dot B is going to give us, we're going to multiply our first terms. So we have -3 times -2 plus our second terms, which is 4 and 2. Whoops. And finally, plus our third terms, which are 5 root 3 times -1. Okay? So when we figure this out, we're going to get 6 plus 8 minus 5 root 3, which gives us 14, minus 5 root 3. I'm guessing they're going to go with an actual number here, so let's calculate this in their calculator. Root 3 times 5. All right. And I don't know how to bring answers up on this. We're going to say 8.66, so 14 subtract 8.66, 5.34. Okay? 5.34. Great. So for A and for B, we have the numerator of the fraction, 5.34, and we know our dot product in the other one's going to be the exact same, 5.34. But what we now need to calculate is our absolute value of A and B for both questions. So we'll go ahead and do both of those. Scroll down to the bottom here. Okay. So absolute value of vector B to start is the magnitude of B. And if you, what is B again? -2. So B is -2 squared plus 2 squared plus -1 squared. Now squaring is going to make everything positive. So we're going to have 4 plus 1, root 9, is equal to 3. So in our first case, 5.34 divided by 3 gives us 1.78. Our second case, absolute value, or the magnitude of A. We're going to write down A is negative 3 squared plus 4 squared plus 5 root 3 squared. Okay. Negative 3 squared is going to give us 9. 4 is going to give us 16. And when we multiply this, I want you to think of it like it's the base multiplied by itself. So when we do this, it's a 5 root 3. Okay. Multiply our numbers in front first. We have 25, and root 3 times root 3 is 3. 25 times 3, what are we going to get? 75. Okay. 75 plus 16, say 15, 20, 91, 100. Is that right? 10? Yeah, it is. All right. And when we divide this by 10, we just move our decimal over 1, 0.534. So those are scalar projections. Back, let's look at both pages. Those are our rules. And those are our scalar projections of A on B and B on A. And if you notice, exactly what we briefly mentioned before, our answers are not the same. Okay? So I know in a lot of our rules before, we're adding them together, and we can add them in different orders, multiply dot products in different orders, we still get the same answer. This one, scalar projections, is not the case.